Today we are moving into graphing linear equations, and we are going to eventually graph lines using 3 points, and then also we're going to have to figure out whether a point is on a given line. And that's the first set of directions. It asks us, without graphing, tell whether each point is on the graph of the given line. So here's an example, letter A. We've got an equation. This is an equation with two variables. We've got an x and a y representing the x-axis, and this represents the y value, the output and the input, or the domain and the range. And we've got ourselves a point. Remember, the point, we always have the first number represents our x value. So this is our x. And then the second number represents the y value. And so all we're going to do to tell whether this point is on the line is take our x value, or 6, and we're going to substitute it in place of the x in the equation. Then we're going to take our y value here, this positive 5, and we are going to substitute that into the y value of this equation. And so when we do that, this is what we have, kind of an order of operation problem. That minus sign in front of the x just means the opposite of whatever x is. So here, x is 6, so we're going to write down the opposite of 6, which is negative 6. Then plus 6 times by, because the y right next to the 6 just means multiply, times by 5. And this should all equal 24. Now if it does equal 24, that means the point is on the line. So we go a little further, and we do the multiplying first. We bring down the negative 6, and that we add 30, and we see if it equals 24. So we go ahead and do the addition here, and since they're opposite signs, we are going to subtract. And when we do subtract, we get 24. So 24 equals 24. So what this means is when the two numbers do agree, we say yes, the point is on the line. And that would be our answer. Well, we've got some other examples here. So let's take a look at them. Let's go with letter B. And let's try one with a fraction. How about 1/3 x minus 2y equals 7. And let's say the point is 9, negative 2. So, got to figure out which ones are x and which ones are y. Remember, it's always the same. Alphabetical order is what you need to remember with ordered pairs. They always go in alphabetical order. So here's our x, here's our y. We're just going to take the x value, 9, and substitute that in place of the x in that equation. And then take our y value, negative 2, and we put that in place of y. And we see if it equals 7. If it does, then the point's going to be on the line. If it doesn't, then it is not on the line. So we go ahead and do that work. We've got 1/3 times by 9. Now, treat 9 as a fraction, so you can see the cross-canceling. Whenever I'm multiplying a fraction by a number, I like to do that so I can see that cross-canceling. And then minus 2, and then in place of the y, I'm going to put negative 2. And this should all equal 7 at the end. And so we go ahead and do this work. Now again, you're going to see some cross-canceling here, so we go ahead and do that. Got this 3 that's going to cancel out this 9, at least go in there a little bit. It goes in 3 times. So what we've got left is when we multiply the 1 by the 3, this 1 here by this 3, end up with 3 minus, now when we look at this, negative 2 times by negative 2, really this is going to become a positive 4 because we have the two negatives. Again, you could treat this one right here as plus a negative. So it's negative 2 times negative 2 makes a positive 4. And this does equal 7. And sure enough, 3 and 4 equals 7. So we'd say, yes, the given point is on the line. Well, let's take a look at another example. Call this one letter C. And let's go with some negative numbers for the ordered pair. How about this one? 5x minus 3y equals 14. And we've got a point of -1, -6. So again, we do the same thing as we had done before. You take those points that represent the x value, which the only point that we have is this one right here, -1. It's always the first number in the ordered pair, and that's going to go in place of x. Let me take this y value, -6, the second number in the ordered pair, and that goes in place of y. And we go ahead and substitute and simplify. So this 5x means 5 times by x. Well, x is -1. Bring down the minus sign, bring down the 3, times by the y value, -6. And this should all equal 14 at the end. So let's see if it does. So when we do the work here, we got to multiply these two numbers. That makes -5. Do the same thing here. Now this is a -3 times by -6. So that makes a positive 18. And then this should all equal 14 at the end. If it does, then the point's on the line. Here, go ahead and do this work. Subtract these two numbers. Oh, it's just off by one number. That only makes 13 at the end. And since 13 doesn't quite equal 14, we say no. The point is not on the line. So either the point is on the line if it equals, or it's not on the line if it doesn't equal. I'll just take a look at one more problem. How about another one with some fractions? Let's go with this one here. X minus 4/5 y equals -10. We'll say the point is 0, and we'll go with about 10. That looks good. So there's our point. Alright, so what we're going to do, same thing as before. We're going to take our x value, and we're going to put it in place of x. So which one's the x? You got it. It's that first number. Same as the ones before. X is always going to end up being first because it comes first in the alphabet. And y comes after x, so that's why that's the second number. That just goes in place of this y right here. And so we go ahead and do that substitution. And here's what we've got. Well, x this time is 0. And then bring down this minus sign, bring down the 4/5, and now we're multiplying by 10. Since I'm dealing with a fraction, I'm going to write this as 10 over 1. Go ahead and multiply that stuff and see if it equals -10. So we go ahead and do some work there. We'll go ahead and do some cross-canceling. And I see that the denominator of that fraction does go into 10. 5 goes into 10 2 times. So now I have to multiply these two numbers right here. 10 multiplied by 2. Or I'm sorry, 4, -4 that is, multiplied by 2. And when I multiply that, I only get -8. Well, that doesn't quite equal -10. So we say no. No, that point's not on the line. The point is not on the line. So those are some examples of problems where we have to figure out whether a point is on a line, and all you do is substitute. And when you substitute, it either equals it, then you say yes, or it doesn't, then you say no. So the next part, we're going to take a look at graphing some lines given 3 points. So you'll see that in part 2.